Good day to our panelists and our advisor, Engineer Arian Palisok. We are pleased to present to you our design project titled Process Design Optimization in the Production Area of Norwan Express Printing Services. To begin, Mr. Torres will introduce the company and its background.
Norwan is a printing press company that prints receipts, flyers, newspapers, notebooks, and many more. They are currently located at Project 3 Quezon City, and Norwan was created in 2010 by Mrs. Joanna Valencia.
Norwan Express Printing Services has three major types of processes, namely pre-press, press, and post-press. Pre-press is the term used in the printing industry to describe the activities that takes place after a commercial printer receives an order from a customer or graphic designer before any actual printing takes place. Press process provides a full range of document production facilities in both offset and digital settings. Post-press is where everything happens after printing the paper.
The proponents use 3RCLE tools, and for the results of the Pareto chart, the proponents will focus on rejects with cumulative percentage of 65.92% and extra processing that has a cumulative percentage of 16.39%. The proponents also prepared a Pareto chart to identify the types of rejects that contributes the most, and based on the 80-20 rule, we have wrinkling and unaligned rejected papers. These problems are resulting in 21.69% opportunity loss, and that is 197,894 pesos and 88 cents worth of opportunity loss every year.
In this part, the designs created by the proponents are listed in relation to the problems identified in Norwan Express Printing Services. Design 1. Cost-effective production system. For the first design, the proponents will propose a machine innovation. The main feature of digitalized printing machine is that the printing process stops when a problem occurs, and the system will automatically identify the root cause, which the operator will calibrate through the touchscreen monitor.
A sheet stacker with a conveyor will also be installed, and it will connect to the bypass tray, which will automatically align the papers as they enter the machine.
The machine is also designed with two program scanners. The first scanner can detect the paper size and displays it on the monitor. Once detected, the operator can adjust the alignment of the paper through the touchscreen monitor. The second scanner can detect if the machine produces wrinkled or misaligned papers, as well as where the error came from. This feature will lessen the occurrence of producing rejected paper.
This digitalized printing machine also has the capacity to print two colors.
Lastly, it has a feature of automatically applying the ink to the ink rollers, and the ink's capacity can be monitored through the system.
Next, the proponents will propose application of automated inspection systems using a surface scanner that will be applied in the proposed machine innovation, and this can lessen the printing of wrinkled and unaligned papers. This will be applied in all three designs.
Predictive maintenance will be implemented for the first design. This maintenance will be supplemented by the installation of a vibration sensor device, which will be used to measure the frequency of vibration in the machine. The vibration sensor will be connected to a CMMS software application, which will provide real-time data that can track when the machine needs maintenance.
Spaghetti diagram was used together with the line layout. The proponent used a U-loop layout for this design, and this layout will reduce the overall travel distance by 15.90 meters.
After the U-loop layout is the implementation of maintenance training with CMMS software, machine operator training, and safety training for the new printing machine. This will allow the workers to gain knowledge and awareness on the machine and also learn about the new process of the company. Not only that, the proponents also decided to recommend workplace rules for the new normal setup in accordance with the COVID-19 pandemic. The expected outcome of this design is to improve the workers' performance and efficiency in the workplace.
The proponents came up with the idea of disposing paper waste in a right container with labels because it does not require as much manual or mechanical sorting as mixed waste, and also to sell paper waste to potential buyers of the wrinkled and unaligned papers that were rejected so they can save money and the environment. It could also be used to fund important sustainability projects of the company.
Design 2. Stabilized Control Management System. For the second design, the same machine innovation from Design 1 will be proposed with the same features.
Second, the proponents will propose automated inspection that will be applied in the machine. This is the same as the first design.
Next to automated inspection is the planned maintenance. This maintenance can be implemented by hiring a technician to perform a planned, documented, and scheduled maintenance activity.
The proponent creates and provides a layout called P-loop layout. With the guidance of this layout, the second design will provide an organized production equipment that will reduce the overall travel distance by 29.084 meters.
Followed by the P-loop layout, the proponents also decided to implement machine operator training and safety training for the new printing machine, as well as recommending workplace rules for the new normal setup in accordance with the COVID-19 pandemic.
Paper waste revenue stream is also the corresponding design that is suggested by the proponents.
Design 3, Worker-Based Operations Management. The same machine innovation from Design 1 and 2 will be proposed for the third design.
For the last design for inspection, the proponents will propose automated inspection, same as the first two designs.
Followed by the automated inspection is the autonomous maintenance that will be implemented in this design. The machine operators themselves will be doing the routine maintenance tasks such as lubrication, cleaning, and inspection of machines.
The proponent will also create and provide a layout called Line Facility Layout. With this layout, the company will have systematic flow of process that will reduce the overall travel distance by 22.60 meters.
Followed by the line facility layout, the proponents decided to implement lubrication and oil analysis on the maintenance training, machine operator training, and safety training for the new printing machine, as well as recommending workplace rules for the new normal setup in accordance with the COVID-19 pandemic.
Lastly, for the third design, it is the same with the other two design alternatives. The summary of results for each design are presented in the table. Based on the summary, all of the design alternatives were able to meet the expected results that were set by the proponent.
The proponents used the following design standards in developing the proposed design. These engineering codes and standards will serve as a guide for proponents to ensure that the designs conform to applicable requirements. The next part shows the pairwise comparison of the three design alternatives. It is clearly indicated that there is no design that dominates the other designs. Design 1 in terms of economic and risk. Design 2 in terms of sustainability and producibility. While Design 3 on environmental and safety.
The sensitivity analysis was used to show the computed normalized data based on the client and proponent's perspective. Both the client and designer's perspective shows that the winning design among the design alternatives is Design 2. After a thorough analysis performed by the proponents, Design 2 is considered to be the winning design, which includes the design components of machine innovation, surface inspection for paper alignment and error detection, and maintenance, P-loop facility layout, machine operator training, and paper waste revenue stream.
This part shows the improvements that will be gained after the implementation of the winning design. Rejects will be down from 17.63% to 2.52%. Travel distance will be reduced by 15.716 meters. Workers' performance will be improved and will be efficient. Rejected papers will be eliminated by turning them into profit. And opportunity loss was reduced from 21.69% to 3.20%, and that is equivalent to 50,860 pesos and 80 centavos.
The proponent's company, iInvest Planning and Design Engineering Incorporated, is a consulting firm that specializes in resolving issues such as reject minimization, maintenance system, process improvements, and facility layout improvement in small to large manufacturing companies. iInvest uses the application of industrial engineering principles, tools, and techniques to provide a wide range of innovative solutions to their clients.
And this brings our presentation to an end. I would like to introduce the proponents behind this project study. We have Mark Dominguez, Jeremy Hardin, Michael Malasa, Kerry Torres, and I, Cara Del Rosario. Thank you for listening to our presentation.